Hi, everyone. This is the SEBA call for February 26, 2019. On the agenda, we have an XOS and NEM general overview and discussion of the migrations, which I think Matteo is going to talk about. If there are any other topics to discuss, let me know, but I think I'm going to hand it over to Matteo. And there's Matteo.
There's Matteo. that doesn't look like ONF. Oh, he has no voice.
Oh, okay, sorry, it was muted. I'm not ONF, Sean. So I hope that now you can see my screen instead of my face.
Yes, we can.
Okay, perfect. So I'm going to start the presentation. So last week we had some questions about NEM, the Synchronizer framework, how it works and what it does for SEBA. So we thought it was a good opportunity to share a little bit of knowledge in what's going on. This is a picture that most of us are most likely familiar with. We have at the bottom the hardware when you use an OLTs, the aggregation switch, the BNG, compute nodes, and everything is controlled by the software running on the compute node. We have Volta to manage the PON side, ONOS to manage both the PON and aggregation switch, and NEM that orchestrate everything. Now, it's time to crack open NEM. NEM is a combination of XOS plus logging capabilities via Elasticstack and monitoring capabilities via Prometheus. The main the main thing that that NEM does is to provide a clear northbound interface that can be used by an OSS, BSS. For example, AT&T is creating OpenOLT that is talking to NEM to manage the entire system. And it also contains an inventory of what is running in the system itself.
I think that's abstract.
Your component,
yeah. Sorry.
OpenOLT is actually part of Volta.
Yeah, you are correct. Let me fix it right away.
So Matteo works right next to Shab, and he hears too much OpenOLT. So
yeah. Okay, thanks Don and thanks Zach. How all these things work together? We have seen that we have northbound interaction with abstract OLT, and we have southbound interaction that works in both directions between NEM and what NEM calls the backend, that are, for example, Volta and ONOS and other pieces in the system. There is also an important role that is played by Kafka that helps NEM to react to events that come from the system. The easiest example of that is the ONU discovery. Whenever we discover an ONU, the ONU sends an indication to the OLT. The OLT reports it to Volta. Volta shows it in ONOS as an OpenFlow port-added event. ONOS published that event over Kafka, and NEM reads that event from Kafka, and then goes on doing the validation against the whitelist and all the other thing it needs to do. Similar use cases are for authentication and DHCP. Again, all the information are coming from Volta through ONOS and then published on Kafka. For XOS, we'll see more detailed examples of how that works in a little while. And Kafka is also used to collect logging and monitoring information from all the system. Again, the OLT, the aggregation switch, Vault, and ONOS publish all the information in Kafka, and these informations are now pushed into Prometheus and Elasticstack to be displayed and consumed by the operator. There was a question this morning on the mailing list about how Kafka helps in case of pod reboot. An example of that is that if ONOS, for any reason, goes down, it runs on Kubernetes. We have a component in NEM that observes the pod in Kubernetes. When you see a pod that goes down, we send an event to Kafka. All the pieces in NEM are aware of that information, and as soon as the pod comes back up, they receive another notification, so they can push again the information down to ONOS to bring it back to the original state.
Matteo?
Yep.
If you cover this later, that's fine. You can defer. But in the picture you have on screen now, you have arrows from the OLT and from aggregation directly to Kafka. Is that a direct communication, or is that through some channel that's not depicted here?
No, this is a simplification. So the OLT stats are published into Volta, and then Volta emits them on Kafka. The aggregation switch stuff are actually published from the switch to ONOS, and ONOS publish them on Kafka.
Okay, that makes sense. And then second question, you show an interface between ONOS and NEM, and then also the interface to Kafka, and then to NEM. What's the nature of the interface directly between ONOS and NEM versus the interface that goes through Kafka?
So these two lines are is NEM talking to different application in ONOS via REST, and this channel is mostly used for top-down communication. For example, if I need to provision the flows to enable a subscriber, we'll see an example of this communication later. While Kafka is used for bottom-up information, so it's ONOS that is saying a device went away, a port went down, or it's publishing statistics.
Okay, was there sorry, and I apologize if these are kind of newbie questions, but was there a reason why the top-down could not go through Kafka?
So it's technically doable. As now, ONOS doesn't have an application that's subscribed to Kafka event. It just has an application that published through Kafka event, while it has a well-documented and pretty stable northbound REST interface.
Okay, makes sense. Thank you.
Also, the other reason is that when you push some instruction down to ONOS, you want to know immediately the result of that action. So having synchronous communication like REST that immediately tells you what is the result of the operation, we thought it's more robust than a send and forget kind of communication, because ONOS publish all the event in Kafka, but it doesn't care if someone actually picks them up. It's not an ONOS concern anymore.
Oh, I see. Okay, thank you. That helps a lot. Thanks.
Sure.
Also, when you say that the OLT and the ag switch publish events to Kafka, is that through a gRPC mechanism that goes up northbound?
So it really depends by the case. In the OLT case, at least in the Open OLT case, the communication between the OLT and Volta is gRPC, and then Volta publishes through to Kafka. In the ONOS case, the communication is via OpenFlow. We can fetch statistics from the device, and then ONOS publish them on Kafka. Okay. There may be in Volta different OLTs that use different adapters and the different communication mechanism between the OLT and Volta.
So my question is that for redfish application in the OLT size, how to recognize the Kafka IP address can do and the producer to the consumer. And, yes.
Yeah, that's set into Volta as a configuration parameter when you start it up.
So you mean the okay?
For redfish specifically, as it's probably lower level than the OLT driver or the aggregation switch, and it would interact directly with the hardware. We currently don't have a way of passing that information on to those systems. I think maybe we would need to provision in Kubernetes the information that would tell us how to get to the Kafka bus, and then maybe we put that in a configuration file that gets pushed the OLT or aggregation switch.
I'm not sure that the OLT. Well, this is maybe a discussion for another time. It's a very good point. I'm not sure that the OLT should talk directly to Kafka. I think it should go through Volta, because some OLT may communicate with Volta inbound, so they may not have access to the management network, and so they won't be able to reach Kafka in any way.
Yeah, that's an interesting point. I think the redfish, which is hardware stats like fans and temperatures and that sort of thing, I had always thought that those would be communicated directly to Kafka, but if they would need to go through Volta, maybe we'd need to figure out a way to expose those API-wise.
Yeah, and I think in the reference diagram it shows the NEM communicating directly to the hardware device. So that may be hiding a lot of details in the high-level diagram.
I'm not sure I got the comment, but NEM is not directly talking with any hardware.
So I'm thinking that the OLT side can do the redfish application to monitor any hardware status report to the Kafka bus or Volta, maybe Kafka process, and forwarding to the Kafka bus. So I want to know that how is OLT side the redfish application can know is which Kafka IP address can do the producer to the somewhere, maybe the same Volta IP address or another IP address. I cannot
Jason,
see in the. Yes.
Jason, I think we understood your question, but the decision hasn't been taken design-wise how that access can be granted to. So I think let's take that offline and come back to you with some design choices. Okay. But for this presentation, let's move on. Matteo?
Okay.
Oh, okay. Thank you.
So I'm glad there were a lot of questions. So please keep asking questions anytime. I think that's a great way to get value out of this presentation. So now we're going to crack open NEM, and in particular XOS, to understand what are its components and what they are doing. Probably some of you have already seen this picture. These are all the components that are involved in XOS. This Kafka you see here is the same Kafka that was brought outside of NEM in the previous slide, because it's more of a platform Kafka than an NEM Kafka, but that's that plays a key role in the NEM functioning. So we have a northbound interface. As you know, we expose Tosca, REST API, WebSocket, and the UI. Everything is automatically generated starting from a gRPC layer that is at this level. And some components actually directly use that gRPC layer. For example, abstract OLT, it's directly talking to the gRPC APIs that are exposed at this level. The central layer is what we generally call the core. It has a data store that is a Postgre database for now. It has some logic in the core that contains all the model necessary for the functioning of the system and the message bus. On the southbound, we have what we call the Synchronizer. We'll see more in detail. Scott was kind enough to prepare a couple slides going into details of the Synchronizer itself. But we can think about them to make a parallelism with Volta as southbound adapters. We have the core that exposes a well-defined API, and the Synchronizer translates this API into backend specific instruction.
So the abstract OLT sits kind of between the core and the northbound interface. Is that what you indicated?
So as part of the northbound, the core exposes a gRPC interface. From that gRPC interface, we auto-generate Tosca, REST, the GUI, and other stuff. But external components are also welcome to directly interact with that gRPC interfaces instead of using REST or Tosca or other systems. So logically, the abstract OLT sits at the same layer of a northbound interface and directly talks with the core. Does that answer your question?
Yeah, I think so.
Okay, so let's move to a more logical picture of what we just say and what happens in the system when we do something. We have a backend at the bottom that can be any kind of VNF, ONOS, or Volta, or in the case of mobile core, it's DPC or the mobile antenna and that kind of stuff. So a set of instruction comes from the northbound, whatever the entry point is, and it applies some changes to the models. These changes in the models needs somehow to be pushed down to the backend, and this is when the synchronizers play those roles. So an example is we want to configure the aggregation switch. We create a switch model in XOS. The ONOS synchronizer receive a notification that such model has been created, and he knows how to translate that model into instruction for ONOS. Same thing happens with the OLT. We create a model in XOS, and the synchronizer is capable of translating that model to a call into Volta. And again, the important thing is that we have a layer of abstraction in the models, between the models and the synchronizer, in such a way that if we want to replace ONOS with another SDN controller, our models will remain absolutely the same. Nothing will change for the operator. We'll have to write this translation mechanism that is the synchronizer in order to adopt a different backend. Is there any question?
Yeah, what is the XOS format? Is it YAML? Is it netconf model you're talking, or is it Tosca model? How?
how the models are described.
Yes, question is that.
Okay.
Thanks.
So the models in XOS are described in a language that is called ExProto. It's something that we created on top of protobuf. So it's basically a gRPC protobuf description of the model with some syntactic sugar and a few features added. There is a very good description on the XOS guide on how this modeling language works, and we use that model models.
Is it
I
part
love
of the
that term,
ONF?
syntactic sugar. Can I get some of that in my coffee?
Is that protocol part of the ONF modeling?
Yeah, it came out of ONF.
Okay,
but
thanks.
it's very, very similar to the Google protobuf. It's based on the Google protobuf. We added some custom extension to that because oh, sorry, there is something in my laptop that is ringing. I don't know what. Okay, let me shut down the notification. And sorry about that. Okay, so moving on.
About
sorry.
the question about models, the Proto models also, I think, are rendered or made available via Tosca as well. So this is where Abstract OLT has really the option or the choice to either interact with the Tosca model or interact directly with the Proto model, really just depending on the granularity you're looking for.
Yeah, so these Proto models are loaded in the core, and the core transforms them in a gRPC interface, and we auto-generate from those same models all these UIs. So you can choose where to come in as Abstract OLT using directly the gRPC interface, or using Tosca, or using JSON, or using the GUI, for example. So now let's make a more concrete example of what happens in SEBA when we create an OLT. We send the models. The core sends an event to the synchronizer. The synchronizer wakes up and says, okay, this is a new OLT. So in order to start it in Volta, I need to make a pre-provision call and then an activation call. Once that activation call is done, it waits for activation, exchanging information with Volta. And once the device is active, it stores that information back in XOS, so that is easily consumable by the operator.
One question before that.
Yeah.
How is the discovery occurring here? Is the discovery already available of the ONU on the Volta?
Yeah, so here we are provisioning an OLT. The discovery happens in a mechanism that is very similar to this one. This one is discovery Volta. Volta notifies ONOS, and ONOS send an event to Kafka. And then we have a flow that is very similar to this one with slightly different operations. So what we are seeing here is a classic example of top-down interaction between XOS and the system. What we see here is a slightly more complex scenario when everything started from a bottom-up event that comes from the system. For example, our subscriber authenticates against the Radius server. Once the authentication goes through, ONOS send an event to Kafka. This event is picked up by one of the synchronizer that updates the model. Internally in XOS, we have this concept of service chain. that basically describe how the models depend on each other. And this is a part of the SEBA service chain. When we have the workflow model that provide information to the subscriber. So every time something changes in the workflow, subscriber model is modified too, and so on through the chain. So when we register in the workflow model that authentication was approved for that subscriber, the subscriber status will change. This will trigger a change in the corresponding virtual OLT model, and this will cause the synchronizer to push the flows into Volta. In the same way, the cross-connect will receive a change that new flows for a specific CNS tag are added in the OLT, and we'll need to make sure that the same flows are published into the aggregation switch to provide connectivity.
Just a small correction. When the Volt synchronizer doesn't actually, it makes the add subscriber call right into ONOS, and ONOS pushes the flows into Volta.
Yeah, that's correct.
So what is the workflow mechanism in the core? Any?
So the workflow, it's a mechanism through which you can basically define a state machine for each particular subscriber that let you manage his life cycle. So you'll have one instance of the workflow for every subscriber in the system, and that will track what is the state, if it is being authenticated, if it has been assigned an IP. And this is where you can specify your custom logic, your business logic, and your triggers to manage subscribers in a different way, because we can see that AT&T wants a different workflow from Dark Telecom that wants a different workflow from Deutsche Telekom, for example.
So subscribers are users, are they devices, or equipments? What does the subscriber mean here?
Here, so these are internal models in XOS. The subscriber contains information to identify it in the system. It will contain information about what are its speed limits and any kind of details, but it doesn't have information about what's the state and what I can do from that state. Because we can see that the information contained in that model will be shared between multiple use cases.
So one thing that could be drawn out from this is the workflow is modular. You could swap out the workflow, the AT&T workflow for the telecom workflow, and other components like the VoLT Synchronizer and Fabric Cross Connect might not need to change, or if they did need to change, it would be very workflow specific. The entire system is designed to be modular so that services can either coexist. So, for example, there's always talk of having a multi-access edge that would have SEBA plus some of the M-Cord services, so that these can all exist and have the API, expose an API northbound that is sort of custom depending on the services being included.
So are you saying that the subscriber belong to one tenant right now here in this?
I guess it depends by the definition of tenant, but as now, SEBA is not multi-tenant yet. So who owns the pod, who owns the hardware, owns all the subscriber in it. What?
So does the ONOS had a tenant framework? ONOS had something called Tenant Model. Is that not being used here? Or underlay is different and overlay is different? Or under, I don't know how to define.
Yeah, that's correct. We don't have, we're not using the ONOS's virtual tenant networking.
But back to, I'm sorry, go ahead.
I'm saying we don't use it in SEBA.
But you can think of subscriber as a tenant. It's a tenant of software as a service, not tenant of infrastructure.
Okay, that helps.
It's a tenant of the connectivity service that SEBA provides.
Okay, if there aren't any more questions, I'll pass the ball to Scott to spend some time talking about the Synchronizer framework. Scott, do you want to present, or I'll just move the slides when you command?
Sure. If you want to just move the slides when I tell you to, that'll work fine. Then we won't have to hand over rights.
Okay.
So the XOS Synchronizer framework. So I'm going to dive into just 3 or 4 slides worth of a little bit of detail about XOS. I'm not going to go into great excruciating detail on it. We do have a presentation from ONS Connect last year where we did go into a lot more detail, and if people want to know more than what I'm presenting today, feel free to ask me for those slides or to schedule a presentation or to view the video from back then. But anyway, on with some discussion of XOS. So in XOS, we've implemented this Synchronizer framework, and the real reason we've done this is because XOS is designed to support a diverse set of heterogeneous services. And when you're supporting lots of very different services, you need different modeling and different logic. So the services are able to contribute their own service-specific models to the XOS core, their own service-specific business logic. And the core, by having all of these in a central place, we're able to create abstractions and overall logic that spans multiple services. So just an example of some of the services that have been in core before. We have, of course, the whole SEBA stack, the Volt, the workflow that Matteo mentioned about AT&T, ONOS Fabric, but we've also supported some diverse things such as, at one point in our past, we had a CDN service that was a first-class object in XOS. So XOS is really designed with that sort of diversity in mind. Next slide, Matteo. And the way we've sort of architected this is we have put different functionality in different containers. So the XOS core is where we have our database and our primary gRPC API. So that was one of the boxes in Matteo's diagram, kind of in the middle. But we have, go ahead. Oh, sorry, I thought I heard something.
No, sorry.
Yeah, and then down at the bottom we have the Synchronizer container. So each of what we call services in XOS will contribute a Synchronizer. And the Synchronizer contains both specifications and it contains code. So we've kind of done this divide where we try to keep we've tried to keep from ending up with like a monolithic bunch of code in the core by keeping this code down in the per service containers. So I've left a few arrows out of this picture just for brevity, but these ExProto specifications, they do get registered with the core when the Synchronizer container first comes up. But the steady state is that the Synchronizer has these policies and steps, and they're constantly watching for events that take place in the core. So, for example, if the foo model changed in the core, you might imagine there's a policy down in the foo Synchronizer which says, whenever I see a change to foo, make this corresponding change to the bar model. So that's kind of an example of putting business logic down in the Synchronizer. It's watching for events, it's applying changes. Back to the data model. So that's kind of half of what a Synchronizer does, is that sort of business logic. The other half is synchronization with external components. And there you're seeing that kind of on the right side. The Synchronizer noticed something in the bar model changed. It executed a sync step, which made a REST call out to some external component. You could imagine this is, in the SEBA case, this is noticing something happen with an OLT or an ONU and making a REST call out to, for example, Volta. Next slide, Matteo.
Yeah, I think it's just important to note that REST is not the only interface between a synchronizer and an external component. This interface can be really whatever your external components speaks.
So yeah, so in the past, oh, go ahead.
No, go ahead, you finish.
Oh, I was just going to say in the past, we have had a diverse set of mechanisms for there. So at one point, we actually had Ansible running inside of Sync Steps, and Ansible could actually SSH into services that maybe they didn't have a REST interface and reconfigure them. We also have examples where we talk to Kubernetes over the Kubernetes API. You could easily imagine using gRPC instead of REST. So this is very much within the domain of the service developer to decide exactly what communication mechanism he wants to his external component.
So question here, the foo and bar services, are they interdependent or they are independent as plugins services?
Yeah, so in this example, foo and bar are models that are both part of the foo synchronizer. Maybe it would have been clearer if I'd have called them, foo 1 and foo 2. So if we do have multiple services, a synchronizer can actually query information about models that do belong to another service, and you can see that example in the AT&T workflow that's part of SEBA. So the AT&T workflow, it does touch things in the OLT service, it touches things in the Fabric service, because it is kind of one of those services that coordinates many different sub-services together.
The other external component, is it a push or a pull or both, just RESTful?
Matteo, can we go to the next slide? I think that'll make this clear.
Okay, thanks.
Yeah, so when we're talking to the external components, we do support both push and pull. So there's both XOS pushing to the external component. That's the first two types of steps. There's a sync step and a delete step. The sync you can kind of think as either a create or an update, whereas the delete is a delete. These sort of straightforward map into REST concepts, but also gRPC concepts with a CRUD API or Ansible playbooks with, creating and deleting. The concepts are portable across APIs, but we have those sort of push steps, but we also have these other steps that are integrating external information. And we support both a pulling, which is, pull in both the sense of, go get something, but also pull in the sense of periodically contact, both PULL and POLL sorts of pull steps. And then we also support event steps, which is basically the synchronizer listening to Kafka events. And then there is that third kind, which is the model policy, which is XOS interacting with itself, noticing a change in one data model object and applying it to another, sometimes spanning multiple services. Does that kind of answer your question?
Sure, it does.
And on to what I think is my next and probably final slide. So yeah, we're going to talk about a little bit of the work that we've been doing during the past month or so, and one of the big steps was some refactoring of the Synchronizer library. So synchronizers have been around with us for several years. They've kind of evolved from what was originally a single use case where we only spoke to OpenStack to these more heterogeneous use cases where we have many different kinds of external services. The implementation was kind of lagging behind, so we took the step to refactor the synchronized framework as a formal Python library. And the benefits in this kind of fit into three different categories. The developer benefit is that we've made the implementation compliant with Python best practices. This is what a Python developer expects. This is how they want their code organized. It's where they're used to doing. There's no crude hacks that confuse people in the implementation like we had before. It works well with their integrated development environments. There's also a community benefit in that we're trying to get more people to adopt this functionality, and publishing these libraries on a place like PyPy that allows people to easily incorporate these libraries into their own components. So the easier you make code for reuse, generally the more people you can expect to try to reuse it. So we definitely want to grow the community and grow visibility into the tools that we develop in ONF. And then there's an operational benefit, which is previously we've had this complex container hierarchy where each level of inherited container installed some libraries, and then another container would layer on top of it, and then another, and then finally you'd build a Synchronizer container. This work is going to enable us to delayer all of those containers to get to the point where a developer just builds a single Synchronizer container, and it will install all of the appropriate libraries from a place like PyPy. PyPy, for those unfamiliar, is a repository of Python libraries on the internet. So this will make the container building process very simple. It will lead to smaller containers, which are easier to distribute, easier to install in an operational aspect, easier to upgrade from one version of containers to another container. I think that's it for my section. Any questions? Okay, Matteo, back to you.
Okay, thanks, Scott. So the other piece of work we have been working on in this last month has been toward enabling ISSU in NEM. The first step to enable that is to support complex data migration. What does that mean? That anytime a model evolves in time, let's say we add a new feature to the subscriber, and we need now to specify his speed profile, we need to do two operations in our system. The first one is to change the database schema so that is up to date with the model. And the second one is to make sure that the data are consistent after the schema change. And there are two very important best practices to do this kind of operation. The first one is to treat migration as code, so we can test them and make sure they work in the same way in the development environment and in the production environment. And we also need to make sure that migrations can be reverted. This is because we release version X+1 of a service, we run it, something goes wrong, we want to roll back to the previous version. So we'll need to migrate the data back to the original state.
Are you looking to enable rolling migration so that you'll have different parts of the pod or different containers within the pod running different versions, multiple versions at the same time? So essentially I want to migrate this pod, then this pod, then this pod.
Yeah, so the migration will be on a per service basis. And if you can or cannot run two versions of the same service at the different time is mainly up to the developer as a choice. It really depends by the migration. But let me go through the next slide. Maybe it's a little clearer.
All right, thank you.
Sure.
Matthew, by migration you mean data model migration, right?
Yeah, correct.
Okay, yeah, please go ahead.
Okay, so as probably most of you know, we have a version 1 of the model. This is a dumb example model. We have a first name and a last name. We want to migrate it to a version 1.1 where we add a full name. And given this change in the model, we have a tool that is capable for you to automatically generate the database migration, adding a field into the table. But then you need to specify some custom logic for this migration, because most likely you want to populate this new field summing the first name and the last name for each user. When we do then a new migration, we now have the full name. We don't need the first and last because we don't need those details anymore for any reason. So we just auto-generate a migration that is going to remove the two names. Now, to go back to David's question, if we make a change from the model version 1 to version 2, then it's very, very hard to have two different versions of the same synchronizer code that runs against this model, because the models are completely different. If we go from 1 to 1.1, then our synchronizer will still work with both versions of the model, and the same when we go from 1.1 to 2.0. So that is really up to the developer to be careful and create incremental migration so that multiple versions of the same service can be run at the same time. Does it make sense, David?
Yeah, it makes sense. So it just means you're migrating your database globally, and it's up to the developer in terms of can both versions handle the new update all at once, as opposed to having kind of a versions database where some services operate off V1 and some instances operate off V2, and then at some point you migrate over. So it makes sense, and it's a hard problem.
Yeah, David, you could do that. This isn't going to help particularly with that, but yes, you could.
Yeah, it's a hard problem to do that type of migration. Don't get me wrong. It's
But you can always do it 1 to 1.1 to 2 in 2 steps.
The point really being is when I've got a deployment, I'm going to try it in Cornfield, Iowa first. No offense if anybody's from Cornfield, Iowa, where I've got 2 subscribers, and get it working there before I migrate Manhattan. But it means in my total system, I'm going to have multiple versions of this running.
But, well, in your global system, at least for SEBA, those are probably going to be 2 separated systems.
But you could recreate, he could have used Des Moines and Cornfield, Iowa served from the same SEBA.
Yeah.
The problem still is still there. So it's going to have to dovetail. It could dovetail very nicely with rolling migration or rolling updates with Kubernetes. But this is still a whole bunch of TBD. This is just one piece of the big.
Yeah, and you're right. And even Kubernetes says I'll upgrade your containers, but that if you've got data that you're operating off of, it's not going to particularly help you there.
Right. So you might imagine an intermediate point where you have 2 different Kubernetes pods, and you're going to have to deal with that in the modeling in the appropriate way.
Yeah. All right. I don't want to derail, and I know it's a hard problem. I'm just curious if you would address it.
This is just a
just one point I wanted to make is there's nothing in XOS that prohibits you from running 2 services that do the same thing but are named differently. So it's just a name spacing thing. You could call one service OLT version 1 and the other service OLT version 2, give each one a totally different set of models, and then manually or out of band through another process move state from one to the other. So XOS would allow you to have multiple services at sort of the service level, and it's just a name spacing thing at that point.
Okay, that's actually helpful. Thank you.
Sorry, let me extend the conversation just slightly. This is a very good kind of a use case or a discussion for use cases. I'm wondering, have any of these types of things, the use cases, or I'm not sure what else to call it, have these been documented in a way that the design of the system could be accommodating of these things?
I think that the point of the system is to give that space for those sorts of business logic and workflow decisions to be implemented. That's that's most of the point of the workflow synchronizers at this point. That some pieces can be reused. For example, VOLT would get used with every workflow that needs access to an OLT, but AT&T and Turk Telekom and Deutsche Telekom could all have their own workflows that interact with it in different ways. Does that answer your question?
Or another way of
no, not really.
Just to tie this together is there could be migration workflows. So AT&T simultaneously could deal with a new approach and an old approach, and their policy. That is a place to implement that logic. It may be not the only place, but it is a place.
No, so I understand from the perspective of designing flexible, modular, that kind of thing. But has the community I don't really even want to say demonstrated, but has the community taken some example use cases or migration, whether it's migration or something else? Has the community taken some examples and written up, even if it's just a one-page description or whatever of how that would actually be implemented?
So I think we just started this work, so I don't think there's been enough time to document everything and show how in a real world use case this will actually work.
We have a very basic guide on how to generate and execute this kind of migration. I think it will be incredibly helpful if the community will come up with like migration examples that they can see they'll need to run on their system, so that we can figure out if what we have can accommodate that, or if we need to add some feature or make some changes to what we are doing.
I think tech profile might be the first good example, because now when Volta tech profile stuff starts bubbling north, I'm sure these models will have to change. So that might be the first opportunity to show it off.
Yeah, and that's basically what we were thinking about when we started implementing this, because we are going to have basically a migration from V1 to V11, because we are going to add some information. Anyway, I encourage everyone to take a look at this guide, and they have the last slide that tried to describe how the migration are actually implemented in XOS. So you generate migration as code, and they are loaded into a synchronizer. As soon as you start your synchronizer the first time, the synchronizer will load the protos in the core, and the models will be generated. The same way it will load the migration in the core, and the core will execute the migration against the database to create the first version of the table in it. When we spin up version number 2 of the synchronizer, we load a new version of the models that replace version 1, and we load a new set of migration that gets run against the database to make the necessary changes. So this is what we are testing now, and it's what we are going to do, as Matt suggested, for a tech profile. We are going to create a new model to host information about the technology profile, and when we load the version 2 of the OLT synchronizer, that will extend the models and extend the database with those new informations.
Matthew, the rectangle box migration, that means the modifications of the existing model, that's what you mean? The box?
This box?
Yeah.
Yeah, so that box represents a set of Python scripts that are partially generated by the XOS Migrate tool and partially written from the developer if there are some custom operation that needs to be done.
Okay.
So what is generated and how to generate it is explained on the court guide. So if you have any question, feel free to ask me or Scott or Zach or whoever in the team. I think we have still 3 minutes, so if there are more questions, we can try to address them now.
Yeah, I have a question on the first couple of slides, also related to the reply on the code dev. So you mentioned the XOS components publish model changes to Kafka. So it picks it up from Kafka and then it is chained in the service chain policy. Is that correct?
No, so the Kafka you see here is the same exact Kafka that you see here. There is just one platform-wide Kafka that is the same that XOS used to publish and listen to events.
If we compare with the other slide when you had the workflow, subscriber, the OLT and stuff like that, so it's only the trigger which is picked up from Kafka. The other modifications or changes in the model are done within the core itself.
Yeah, so these changes, these horizontal red arrows, are actually done through the Synchronizer model policies. The mechanism Scott was describing to do XOS to XOS changes.
All right. Yeah. From the reply, I got an impression like all the model changes are pushed through Kafka. I mean, these are also model changes. Right?
So all the model changes are reflected to Kafka, so people can listen to that. But Kafka is not changing the model. Kafka is only acting as a trigger so that a synchronizer can, through the model policies, change the model.
Yeah, that clarifies. And also you mentioned about example of a Kubernetes pod going down and you need to give the information to them. So my understanding was it's taken care of by the replication controller in Kubernetes, right? So what exactly are we doing with NEM taking care of this?
What happens is that let's make the example again that Onos goes down.
Okay.
Let's say that we have like 3 subscriber provision in Onos and 2 cross connect configured in Onos.
Yes.
When the Onos container goes down, Kubernetes will start a new container.
Okay.
As soon as it starts, we'll receive an event on Kafka.
Okay.
And all the synchronizers that are interested in Onos are listening for the event Onos came back. And they will make sure that the 3 subscriber and the 2 public cross connect are still correctly provisioned in Onos. If not, they will push those information again so that connectivity is maintained.
So you re-verify the work, the state again?
Yeah, correct. We make sure that the state is the same as before Onos went down.
Okay, that clarifies. Yes.
We are not really taking care of the life cycle of the container. We make sure that once the container is up and running again, the state is what we expect it to be.
Yeah, that's what I mean. If it re-verifies the state, that clarifies why it is. And also the slide on pushing the events from OLT ONU to Kafka. So that includes both logs and metrics, right?
Yeah. So for this slide, if you look at the presentation, we had that ONS Europe or BBWF or even ONF Connect, you'll find a more detailed description. But we have logs that are going from all the components, including the XOS, into Kafka, and we read them in Elasticstack. And through Volta and Onos, we have information going to Kafka about the statistics, and they are fed in Prometheus.
Okay, so just a quick question around that. The Volta KPI exporter, so is that the component which takes the information from OLT and puts into Kafka, or Prometheus directly takes it from the exporter?
No, the KPI exporter sits between Prometheus and Kafka, because Prometheus is designed around a poll-based mechanism.
Okay.
Basically, the KPI exporter listens to Kafka and exposes northbound REST API that Prometheus can follow.
Yeah, that clarifies it. Thank you.
Theo, I have a quick question. We are out of time, but so I wonder how did you integrate abstract OLT and XOS? For example, the provision API call. I think it is not a part of the model file. So did you implement directly into the Synchronizer or web servers? I don't know. Or so how did you open?
Don can probably address this question much better, but I believe that what they are doing is that they are not doing a pre-provision call to NEM. They are creating an OLT model, and then is the VLT synchronizer that takes care of all the calls that are needed in Volta. Abstract OLT is just operating at XOS level using its model as you will do with Tosca or the REST API.
You're correct. You're correct, Matteo.
Yeah, the synchronizer actually, once the model is populated, the synchronizer will call pre-provision OLT, we'll call enable, and then we'll reach into ONOS and set up the placeholder for the OLT to fit into an OLT pipeline. But all of that ends up being driven from the Tosca model or Proto model, delivered via abstract OLT.
Yeah, so this is exactly what happens. We create an OLT device model from a northbound interface, whether that is Tosca, REST, or gRPC. It's completely transparent for everything that happens in the southbound.
I see. Okay, thank you.
I mean, it's the same way with adding ONUs and adding subscribers. There's details I don't care about. I just want to kick off the workflow.
So ONU,
and then XOS itself figures out what all has to happen and synchronizes.
Right. The ONU discovery is synchronized from bottom up. So when Volta tells ONOS, Kafka synchronizer said there's an ONU here, then the synchronizers say, oh, what am I going to do with this ONU? And in the default case, it may be just lock it, or in other cases, it may be push eat flows.
Right. Well, I mean, but I say add it to the white.
Yeah. So
then that allows lots of other flows and everything else that has to happen to make that functional.
Right. Abstract OLT just says that ONU is in the whitelist, and here's the subscriber placeholder with SNC VLANs and NAS port ID for when it comes available.
Okay, thank you.
Okay, well, if there aren't any other questions, thank you, Matteo and Scott, for presenting, and thanks everyone for the questions. I'm going to, it's past the top of the hour, so I'm going to end the meeting. Thank you, everyone.
All right, see you, Zach.
Bye.
Thank you.
Thank you, guys.
Nice.
Bye.
Thank you. Bye.